Good day everyone, this is our Chapter 6, Fluid Flow Measurement of Head Loss Measuring Devices or the orifice. Problem 1. In the picture, the cylinder weighs 120 kilograms and weight of 300 kilograms. If the cylinder is empty at the time the orifice is open, determine the time required for the cylinder to sink in 0.60 meters, neglecting the thickness of the cylinder wall. But before we answer our problem, let us first take a look at this illustration shown above. So what is an orifice? An orifice plate is a device used for measuring flow rate or for reducing pressure or restricting the flow. As you can see here in this illustration, this explains how an orifice could be a good help in a tube or in a pipe. Meanwhile, in this illustration, it explains the differences and the function of orifice flow meter, nozzle flow meter, and venturi flow meter. For more informative videos, you may visit this link below. So to solve for the time required to sink for 0.60 meter, first, let us write down here the given in the problem. So mass is 120 kg and 300 kg, the depth of 0.60 meters, and the specific weight and the density of the concrete, which is 24,000 kilograms per cubic meter, which is multiplied with specific gravity times the specific weight, which is 2.4 times 1,000. The constant of A, which is 0.0012 square meters, and C of 0.60. The concrete has 2.4 specific gravity. So first, let us solve for the weight 2. So weight 2 is equals to the area times height times the specific weight and the specific gravity. The buoyant force has a formula of area times the depth and the specific weight. So first, solving our weight is equals to mass times the gravity is equals to the volume times the density. So our density is 2,400 kg per cubic meter times the volume and the gravity. So we have here our now is our 300 kg is equals to the volume 1 times the density. So our answer is 300 kg equals to V times 2,400 kg per cubic meter. To get our volume, we need to first multiply 2,400 kg per cubic meter in both sides and get the answer for 300 kg divided by 2,400 kg per cubic meter, which then results to the answer volume is equals to 0.125 cubic meter. Next is solving for the buoyant force, which is written as buoyant force is equals to area times the depth times the specific weight, or buoyant force is equals to the volume times the rho g. The density of the water is given as 1,000 kg per cubic meter. Solving for the buoyant force 2 is equals to 0.125 cubic meter times the 1,000 kg per cubic meter. Cancel the cubic meter from both sides, so we can have our answer as 125 kg times the gravity. So our answer would be 12.5 kg. Cancel both sides, the gravity, the depth, and the area. Our answer would become mass is equals to 12.5 kilograms. After this, we can solve the buoyant force 1 of 1,000 kg per cubic meter times the area and height. So buoyant force is equals to the rho g times area times height. So solving it with both sides, our answer left would be rho times the volume, 1000 kg per cubic meter times the 0.2827 square meters times height. After this, we can get the answer as rho times volume is equals to 282.7 kg per meter times the height. And finally, to get the answer for the submerged orifice, we can first get our total value for H. So our formula would be buoyant force 1 plus buoyant force 2, which is equals to 120 kg plus 300 kg mass 1 plus mass 2. So we have here our answer, but before that, we must plug in all the values that is given in the problem, which is 282.7 kg per times the height plus 125 kilograms is equals to 120 kilograms plus 300 kilograms, which is then equals to 282.7 kilogram per meter times height equals 120 kilogram plus 300 kilogram minus 125 kilogram. To get our answer for H, we must multiply both sides by 282.7 kg per meter. So in multiplying in both sides, we may cancel out 282.7 kg per meter in the other side and multiply it and divide it from the other side, which would become H equals to 1.0435 meters. And finally, to solve for our formula for the submerged orifice, using the formula Q is equals to CA times the square root of 2GH. Solving for the time required, first is getting the discharge with the formula Q is equals to CA times the square root of 2GH. Q is equals to 0.60 times 0.00130 square meters times the square root of 2 times 9.81 meter per second squared multiplied by 1.0435 meters. And our answer would be Q is equals to 0.0352 cubic meter per seconds. So this discharge will be plugged into the formula T is equals to the volume over the discharge. Solving for our volume would be pi over 4 times the diameter of 0.60 meter squared times 0.6 meter over our discharge, that would be 0.0352 cubic meter per seconds. Cancel both sides for the cubic meter and get the answer for the time required as 48.196 seconds. And that would be all for our chapter 6. Thank you for listening. Please like, subscribe for our channel.